Okay, in this section, 1.3, in our textbook, you can see students will be able to use function notation and use functions to solve real-world problems. Our function notation can be written several ways, but this first one, in a function notation, you will see y equals f of x, and that's exactly how you read it. Our x and y values are in their corresponding locations, x being the independent variable, or we said domain, input, any of those words would work, where y was our dependent variable, output, result, those are the choices. This form of notation where we have our y equals f of x is said to be called the Euler's notation or f of x notation. Two names for the same exact thing. Now, when you look at this, the f doesn't have to be an f. F is in a position where it could be called the indicator. When we say the indicator, meaning an index, a name, it sort of helps identify what you're doing. So when you look at, on the next slide, an example of evaluate the function for the given values of x. You see the function written up top is f of x equals negative x squared plus 4x minus 1. And it says evaluate this when x equals 2 and x equals 4. You can't do both of those at once. You can only do one at a time. So we're going to start with the x equals 2. With x equals 2, you will put a 2 in wherever there is an x. So I placed one here, here, and here. And you can see the work that we've done. Put the 2 in, you got to start doing the math, you got to follow order of operations. So we did the powers first, got a 4, but the negative sign still makes it a negative 4. We got the multiplication, 4 times 2 is 8. With the subtract 1, we've got f of 2 equals, keep working, and we finally come down to get a value of 3 after we do order of operations. That means when x was 2, y came out to be 3, we have a final ordered pair of 2, 3. So when we put an x in, the result or the outcome was 3. So again, all we've done is the x equals 2 part. We now need to tackle the x equals 4. So when x is 4, you should be looking at doing the same exact thing. So I want you to practice that. And so that means f of 4 would look like this. The opposite, you're putting a 4 in wherever there's an x. And now that leaves you to do the order of operations. And so do the order of operations on that. Again, 4 squared would give me 16, but the opposite of that would make it negative 16. Plus 4 times 4 is 16, and then subtract 1. Keep doing the math again. We could have brought the f of 4 down. We're not really doing anything on this side of the equation. But we know negative 16 and 16 is 0, and 0 subtract 1 leaves us with a negative 1. So in this case, our final ordered pair would be 4 was our x value, and negative 1 was our y value. So you're not going to be able to evaluate the function for both values at one time. You have to do them separately, like 2 separate problems. The second type of function notation is called arrow or mapping notation. It's very similar, but written with a few different symbols. So look at this one. W is my identifier. W is in the same position the F was previously. X is the independent variable, so the location of the independent variable is there. Then you see an arrow, and then you see 4x minus 1. 4x minus 1 is our rule, our function, where we're going to be doing our work in this equation. That's what you would call that. So, read as W maps x onto 4x minus 1. W is the identifier, maps is our arrow, x is the independent variable onto our rule, 4x minus 1. So in this case, when I say W maps, W maps the number 23 onto what? We want you to use the same exact rule. So in your brain, you should be saying, well, wait a minute. If I use that exact same rule, then my W rule is 4x minus 1. Wherever there is an x, I must put in that 23 and do the math. 23 times 4, 92, take away 1, 91. You would say W of 23 is 91. Fill in the blank. So it's same as saying we put a 23 in, we get a 91 out. It's just a different way of writing it. You should be able to go from arrow notation to mapping arrow and mapping notation are the same. You should be able to go from arrow or mapping to f of x or Euler's notation. As an example, doing that, I would have said W of x, what's my variable, equals, now I'm asking, what is that rule? What is that calculation we had to do on this one? And it was to take 4 times our x and subtract 1. So here's an example of arrow or mapping notation. Here is our Euler's or f of x. F of x is definitely going to be used more than arrow notation. So that's all for today. We'll practice that a little more when we come to class, and we should be good to go. Bring your questions with you to class.